Welcome back to our data science series. Today, we're pulling back the curtain on a part of AI that rarely gets the spotlight, but is absolutely essential: data preparation. While most people imagine AI as a world of fancy algorithms and futuristic robots, the truth is, data scientists spend up to 80% of their time cleaning and prepping data. Think of it as the behind-the-scenes work that makes the magic possible. Without this step, even the smartest AI would be lost. Let's bust the myth that AI is all about code, because, in reality, it's all about the data. Imagine raw data as freshly mined gold ore, full of dirt and rock, not ready to be turned into beautiful jewelry just yet. Data preprocessing is the entire pipeline of cleaning, transforming, and organizing this raw data so it's suitable for a machine learning model. If you skip this step, your AI model is likely to fail, no matter how advanced it is. Just like you wouldn't cook with unwashed vegetables, you can't build reliable AI with messy data. Let's see why this process is so critical. It's a golden rule in computer science: garbage in, garbage out. If you train an AI model on messy, incorrect, or duplicate data, its predictions will be completely useless. Data cleaning ensures your model is learning from accurate, high-quality information. Think of it like making sure your recipe ingredients are fresh and measured correctly, otherwise, your dish won't turn out right. Clean data is the foundation of trustworthy AI. Missing value happens when no data is stored for a specific feature in a record. It might show up as a blank space, none, or null in your dataset. Why does this happen? Maybe a customer skipped a question on a survey, a sensor lost power, or data got corrupted during transfer. Missing values are like missing puzzle pieces. They can make it hard for your AI to see the full picture. Recognizing and handling these gaps is a key part of data preparation. Can't just leave blanks in your data. Most AI algorithms will crash if you do. Data scientists use two main strategies: deletion and imputation. Deletion means removing rows or columns with missing data, which works if you have a huge dataset and only a few gaps. Imputation is like smart guesswork. You fill in the blanks using the mean, median, or even another AI model. Choosing the right approach keeps your data solid and your AI running smoothly. Outliers are data points that are drastically different from the rest. Imagine a neighborhood where 99 people make $50,000 a year, but one resident is a billionaire earning $100 million. That billionaire is an outlier. Outliers can heavily distort your AI model's perception of reality if not handled properly. Spotting and managing outliers is like making sure one super spicy pepper doesn't ruin your entire dish. Normalization is the process of scaling numeric data so all values fall within a specific tight range, usually between 0 and 1. Why does this matter? If one feature is age, 0-100, and another is salary, $20,000-$1,000,000, a computer might think salary is 10,000 times more important just because the numbers are bigger. Normalization puts everything on a level playing field, making sure your AI doesn't get confused by scale. Standardization is another way to rescale data, but instead of squeezing everything between 0 and 1, it centers the data around a mean of 0 with a standard deviation of 1. This creates a classic bell curve and tells the AI how far away each data point is from the average. It's like adjusting all your ingredients to match a standard recipe so nothing throws off the final result. Sometimes you just don't have enough data to train your AI. That's where data augmentation comes in. It's like making more cookies by cutting your dough into different shapes. For example, if you have 100 photos of cars, you can rotate, flip, zoom, or change the brightness to create 1,000 unique training images. Data augmentation helps your AI learn more from less, making it smarter and more robust. Structured data is highly organized, neatly formatted, and easy to search. Think of anything that fits perfectly into a traditional database table, spreadsheet, or SQL database. It consists of clear rows and columns with defined data types like dates, numbers, and strings. Structured data is like a well-organized pantry. Everything has its place and is easy to find. Structured data is information that doesn't fit into a neat, predefined layout. In fact, it makes up about 80% of all data in the world today. Examples include emails, PDFs, YouTube videos, audio recordings, and social media posts. This chaotic data is exactly why we need modern AI and deep learning to make sense of it all. It's like sorting a messy closet where nothing is labeled. CSV stands for comma-separated values. It's the most common file format in data science. A CSV is a plain text file where each line represents a row of data and each value is separated by a comma. Because it's lightweight and simple, almost any programming language or software, like Excel, can open it instantly. CSVs are like universal containers for data, making sharing and analysis a breeze. Exploratory data analysis, or EDA, is the detective work of data science. Before building a model, you spend time exploring the dataset to understand its secrets. During EDA, you look for patterns, spot anomalies, check the distributions of data, and see how different variables relate to one another. It's like being a detective searching for clues before solving a mystery. Data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and heat maps, data visualization makes it incredibly easy for humans to see trends, outliers, and patterns that would be invisible if you were just staring at a spreadsheet of raw numbers. It's like turning a complicated recipe into a simple picture. High data quality means your data is accurate, complete, consistent, and up-to-date. If your data quality is poor, the consequences can be severe. Self-driving cars could misinterpret signs, financial algorithms could lose millions, and medical AI could misdiagnose critical health conditions. In machine learning, quality always beats quantity. Reliable data is the backbone of safe and effective AI. Data bias happens when the dataset used to train an AI model systematically overrepresents or underrepresents certain groups or outcomes. Because AI learns by copying patterns from past data, any historical prejudices or skewed sampling will be baked straight into the AI. For example, if a facial recognition system is trained mostly on light-skinned faces, it will struggle with darker skin tones. Data bias is one of the biggest ethical challenges data scientists face today. Let's walk through the typical data preparation pipeline. It starts with collecting raw data, then moves to cleaning, handling missing values, transforming, and finally, splitting the data for training and testing. Each step is crucial. Skip one, and your AI could stumble. Think of it as prepping ingredients, cooking, and plating a meal. Every stage matters for the final taste. Data preparation is a lot like cooking. You wouldn't serve a meal without washing, chopping, and seasoning your ingredients. Similarly, you can't build a reliable AI model without cleaning, organizing, and transforming your data. The better your prep, the tastier the results, whether it's dinner or data science. Think of data cleaning like tidying up your room. If you leave clutter everywhere, it's hard to find what you need and easy to make mistakes. Cleaning your data means removing errors, duplicates, and inconsistencies so your AI can work efficiently, just like you can focus better in a clean space. Not all missing data is the same. Sometimes, values are missing completely at random, while other times, there's a pattern, like customers skipping a sensitive question. Understanding why data is missing helps you choose the best way to handle it. It's like figuring out why an ingredient is missing from your pantry before deciding what to substitute. Handling missing data, deletion is quick, but can throw away valuable information. Imputation keeps more data, but requires careful guesswork. The choice depends on your dataset size and the importance of the missing values. It's a balancing act, like deciding whether to skip a recipe step or find a creative workaround. Spotting outliers is a key part of data exploration. You can use charts, graphs, or statistical tests to find values that don't fit the pattern. Outliers might be errors, or they might reveal important insights. Either way, they need special attention before you build your AI model. Normalization helps your AI model treat all features fairly. Without it, features with large numbers can dominate the learning process, leading to biased results. By scaling everything to the same range, you ensure your model pays equal attention to every detail, just like a chef balances flavors in a dish. In practice, standardization is used when your data doesn't have a fixed range or when you want to compare features with different units. For example, comparing heights in centimeters and weights in kilograms. Standardization makes these features comparable, helping your AI model learn more effectively. Data augmentation isn't just for images, it can be used for text, audio, and more. For text, you might swap words with synonyms or shuffle sentence order. For audio, you can change the pitch or speed. Augmentation helps your AI generalize better, especially when real data is limited. Common examples of structured data include sales records, customer databases, and inventory lists. These datasets are easy to search, filter, and analyze because they follow a consistent format. Structured data is the backbone of traditional business analytics. Structured data includes things like emails, social media posts, videos, and audio recordings. These don't fit neatly into tables, making them harder to analyze. Modern AI techniques are designed to extract meaning from this messy, real-world data. Let's look at a simple CSV file. Each line is a row, and each value is separated by a comma. For example, name, age, salary. This format is easy to read and write, making it the go-to choice for sharing data between programs. Visual exploration is a big part of EDA. By plotting charts and graphs, you can quickly spot trends, clusters, and outliers. Visual tools make it easier to communicate findings to others, turning complex data into clear stories. During EDA, you're on the lookout for patterns and anomalies. Patterns might show a relationship between two variables, while anomalies could signal errors or rare events. Spotting these early helps you build better AI models. Humans are visual creatures. Data visualization turns raw numbers into pictures, making it easier to spot trends and make decisions. Whether it's a bar chart, line graph, or heat map, visualization is a powerful tool in every data scientist's kit. Imagine a self-driving car misreading a stop sign because of poor data quality, or a medical AI making a wrong diagnosis. These real-world consequences show why data quality is non-negotiable. High-quality data saves lives and money. Data bias can have serious consequences. If an AI is trained on biased data, it can reinforce stereotypes or make unfair decisions. That's why data scientists must constantly check for and correct bias, ensuring AI serves everyone fairly. Well-known example of data bias is facial recognition systems that perform poorly on people with darker skin tones. This happens when the training data is mostly light-skinned faces. It's a reminder that AI reflects the data it learns from, for better or worse. Ethics is a growing field in data science. Data scientists must consider the impact of their models on society, from privacy concerns to fairness and transparency. Responsible AI starts with responsible data preparation. Bad data can cost companies millions, damage reputations, and even put lives at risk. That's why organizations invest heavily in data quality checks and audits. It's like regular maintenance for your car. Ignore it, and you'll pay the price later. There are many tools to help with data preparation, from spreadsheets like Excel to specialized software like Python's Pandas library. These tools automate cleaning, transforming, and analyzing data, making the process faster and more reliable. Despite all the tools, human judgment is still essential in data preparation. Data scientists use their experience to spot issues, make decisions, and ensure the data tells the right story. It's a blend of art and science. Data preparation is often a team effort. Data scientists, engineers, and domain experts work together to ensure the data is accurate and relevant. Collaboration leads to better results and fewer mistakes. Data preparation isn't a one-time task. As new data comes in, you need to keep cleaning, updating, and checking for errors. Continuous improvement ensures your AI stays accurate and relevant over time. You've covered the entire journey of data preparation, from raw, messy data to clean, organized, and bias-checked datasets. Each step is vital for building trustworthy AI. Remember, the best AI models are only as good as the data they're trained on. Data preparation is the foundation of data science. Clean, well-structured, and unbiased data leads to better models and safer AI. Whether you're handling missing values, normalizing data, or checking for bias, every step matters. Quality always beats quantity. As AI evolves, so do data preparation techniques. Automation, smarter tools, and better collaboration will make data prep faster and more reliable. But the core principles, clean, accurate, and fair data, will always remain the same. With a solid understanding of data preparation, you're ready to tackle real-world AI challenges. Remember to use the right tools, collaborate with others, and always prioritize data quality and ethics. Your toolkit is now stronger than ever. That rounds out our deep dive into data science and data preparation. Now you know how raw, messy data is cleaned, transformed, and checked for bias before it ever touches an AI. Stay tuned for more insights as we continue our journey into the world of artificial intelligence. See you next time.